Welcome to a geography lesson. Today we're going to revise paper 1, the theory paper. And in this paper we're going to have a look at two sections. Section A consists of question 1 and 2, that consists mostly of climate and geomorphology questions. And then we have section B, that's settlement and economic geography. Keep in mind that you only need to answer 3 questions when you do paper 1. Okay, let's get straight to it and let's look at some of the questions. The first question, refer to figure 1.1 showing a graph. Okay, so a graph, this is certain information provided to us. And it shows the conditions of the mature stage of a tropical cyclone. What do we know about a tropical cyclone? It's a low pressure system because it's the cyclone. And we know it forms in tropical areas from 5 degrees and 25 degrees north and south of the equator. But let's quickly have a closer look at our graph. Okay, the one line graph, the solid line represents the wind speed. Now immediately what I can identify, the wind speed increases towards the eye, as you can see over there. The wind speed is the highest to the eye wall. And if you look at the pressure, the graph that's represented by pressure is a dotted graph line. The pressure is the lowest around the eye wall. And as you can see, the movement, direction of movement is from east to west and recurs back in the easterly wind belt. But let's quickly go and have a look at the questions that's being asked. Our first question, state the type of precipitation at A. Now, if you look at tropical cyclones, they are quite devastated, it causes great devastation. So what type of precipitation will we find at A? Definitely heavy rainfall. And that will be your correct answer. Now, tropical cyclones is associated with a lot of rainfall over a very short period of time and very strong winds. Now 1.1.2, state where the highest wind speeds is recorded in the graph. And I've shown you this on the previous slide. If you look at it, where is the highest recorded wind speeds? Here's a graph for wind speeds, as you can see, situated around the eye wall. So we can just write over there next to the eye wall. Okay. If we look at our next question, name the main cloud type that surrounds the area B. Now that's heavy rainfall clouds. What do you associate with heavy rainfall clouds? Is cumulonimbus. And as you know, in grade 10 you learned about the different clouds. Nimbus means rain. Now 1.1.4, give the term that describes the air movement towards B. Now let's quickly go and have a look where B is. And what happens at B? What's the air movement over there? Very importantly, it's convergence of air. Okay, that's what, when air moves towards one another, or anything moves towards another, is known as convergence. So 1.1.4, convergence of air. Now give a reason for the air movement at B. Now simple reason what happens over there. The air rises and then there's divergence in the upper atmosphere. If you look at the diagram over here, as you can see, there's upper air divergence. That's the reason the air rises. Then there's divergence up in the atmosphere, and that's the reason we have clear blue skies. So the correct answer over there, upper air divergence. Upper air divergence. Now, in which area does the tropical cyclone experience the lowest pressure? And that's quite an easy reading from your graph, as you can see, the lowest pressure is experienced at the center of the eye. We can just write the correct answer over here, right in the middle of the eye, or the middle of the tropical cyclone. Now, why does the air descend into E? As you can see over there, usually when we associate tropical cyclones, the eye, it's clear blue skies in this column over here. As you can see over there, there's usually no cloud cover over there. What's the reason for that? It's because of the upper air divergence, so the air sinks over there. Upper air divergence causes air to subside. Subside means sinking in the middle of the tropical cyclone. Okay, so that is question 1.1. Let's continue with question 1.2, showing us, if you look at the diagram, figure 1.2, a section of a river. Now, immediately before we look at the questions, let's just quickly identify this. Now, first of all, I pick up on a couple of things. The term meander. And I know meandering only takes place in the lower course of the river. Why? Because it's where deposition takes place. And if you look at the characteristics of meandering, you've got the cut-off slope and the slip-off slope. Undercut slope, also known as the undercut slope, and the slip-off slope. And I know over here, erosion is taking place because the water bumps into the side, and I know at A, deposition is taking place. And if you look at C over there, there's A and B that's been represented on this diagram next door. Then this D is known as the meander neck, C is known as an oxbow lake. But let's go and look at the questions. Now, grade 12s, this is how I want you to answer your questions with your question paper. You need to be able to relate and know what's being asked in the diagram before even looking at the questions. But let's quickly go and look at the questions. Name the course of the river depicted in figure 1.2. Now, first of all, immediately, as you can see, meandering is taking place. And the only time the river starts to meander is in the lower course. So the correct answer is the lower course. It can meander in the middle course as well, but the chances for meanders for oxbow lakes is more prone to happen in the lower course. Name the riverbank B. If we quickly go and have a look, there's riverbank B, and that is known as the undercut slope. Okay, let's look at question 1.2.3. Give a reason for the deposited material at bank A. Now, if you look at bank A, you can see the deposited material on the inside bend. And the reason for it is because it's in a lower course of the river. So we can say that because the riverbed is shallow. Another reason that we can mention in 1.2.3 is the carrying capacity of the deposited material is decreasing. And because of the slow movement of water. Now keep in mind there's only deposition taking place in the final stages of the lower course. Describe the shape of the river bank. Question 1.2.4. The shape, if you quickly look at it at number B, B will have, if you had to draw a transverse profile, it will be a concave slope. And the correct answer for for 1.2.4 is concave. Now 1.2.5, name one characteristic of a river channel that can be seen in the cross section between A and B. Now first of all, if you look at the characteristic between A and B, we can see that the river is very wide. The width of the river, that's correct, you can mention that, that's definitely a characteristic. The width. We can always look at the bank shapes, like for instance, the concave shape on the cut slope, and then obviously how deep it is as well. Now if you continue with question 1.2.6, did river erosion or deposition initially form the Oxbow Lake at sea? The Oxbow Lake is this area over here. And the correct answer will be erosion. It's erosion, that's how it has formed. Now the simple reason, if you look at it, your river meandered. And what happens over time? It will erode straight through over here at the cutoff slopes, and eventually over time your Oxbow Lake will be separated from the river. State one difference between an Oxbow Lake and a meander scar. Now the only difference is the same thing, but the Oxbow Lake have water in it. There's water in it, and the meander scar is dried up. Uh, 1.2.8, what is the narrow area D within the meander loop called? If you quickly look at that narrow area, it's this area over here between it, and that is known as the meander neck. I've already mentioned that to you, so that's the correct answer. Meander neck. Okay, and that was our short questions. Now let's quickly look at question 1.3. It's a sketch map showing bergwind conditions. Now bergwinds usually happens during the winter. Now it's very easy to be able to see what's happening over here. Now we're going to look at some clues over there. First of all, my first clue, there's a high pressure system present, and that over the interior is the Kalahari high pressure system. Then we have mid-latitude cyclones taking place in the winter. There's the cold front, as you can see, approaching from west, moving all the way to east. And then we have a low pressure system that's known as a coastal low pressure on the coastline. So just by looking at this figure, all the conditions necessary for the formation of a bergwind is right in front of us. Now let's quickly go and have a look at the question. Our first question states, name two conditions visible in the sketch map that's unnecessary for the bergwinds to form. Now first of all, I'm going to mention three. There's a very strong subsidence, there's a high pressure cell over the interior of South Africa, there's a cold front low pressure system approaching, and there's a coastal low pressure if you look at the sketch over there at the coastline. So let's go and write it down. I'm going to write three down because we can identify each and every single one of them. Now the first one, presence of the Kalahari high pressure over interior, and the presence of a coastal low pressure of a coastal low pressure, and approaching mid-latitude cyclone. And what is a mid-latitude cyclone? Is basically the cold front. That's what we experience in Southern Africa. Now, if you look at our next question, now this is a very important question to me. Basically, I'm going to explain Bergwind conditions to you now. Draw a labeled cross-section to explain the formation of Bergwinds along the east coast of South Africa. Now, first of all, a cross-section. So I'm going to draw a cross-section from the interior to the coastal regions. Now, very importantly, we got a high pressure and a low pressure down, a high pressure over the interior and a low pressure down at the coastal areas. And by now, grade 12, you should know that air travel from a high pressure to a low pressure, and that's known as wind. Now, in the case of Bergwinds, what do we have over the interior? We have the Kalahari high pressure moving in an anti-clockwise sinking air. Now we have a low pressure at the coastal regions. Air moved from a high pressure to a low pressure. Now what happens with the temperature once it's moving down with altitude? Now keep in mind, what happens, for instance, you go and climb Kilimanjaro. What's going to happen with the temperature? It's going to decrease. Now we're moving roughly from an altitude of 1,600 meters. Now temperature decreases for every 100 meters with 1 degree Celsius. So what do we say? The air is descending, it's sinking, it's moving down the escarpment. That's the reason why we call it Bergwinds. And it heats up adiabatically. Okay, so it's subsiding air from the interior of South Africa, and there's a coastal low pressure down in the coastal region, so it moves from the escarpment, from the plateau, over the escarpment, all the way to the coastal low pressure. So what happens is air heats up adiabatically, because for every 100 meters it decreases in altitude, it gets 1 degree warmer. And that's the conditions regarding Bergwinds. Now, why are Bergwinds most likely to occur in winter? Mainly because of the strong presence of the Kalahari high pressure system. Okay, during summer, it's not, because of warm conditions, the subsistence is not that strong. Question 1.3, we will quickly answer question 1.3 directly after the break. Stay tuned, see you in a bit.